The van der vos Reynaerde is studied from the 13th century, and we don't actually know the author of this poem. The only thing we know, more or less, is from the first verses of the poem itself, which recite Willem die Madoc maakte. So if you know a bit of German, or if you jump from English, you might see that it's Willem who made Madoc. So we only know an author by its name and by another work they did, but we don't have anything about the other work. So there has been a very long, almost sometimes speculative tradition in philology, in Dutch philology, trying to understand who the author was, what we can understand about his life, his profession, or where his inspiration came from for rewriting this poem, because it's one of the most important pieces of literature in medieval Dutch literature. So it's, if you want to compare it to something, it's not like our Divine Comedy, but it has some parallels to it, especially for the long tradition that it has inside the theology. So basically, it's kind of a Homer case in which we don't know if it was one author only, or if it was two authors, or who exactly the author was, or if it was just a pseudonymous. So I've worked with a colleague that you might know as well, Valentina Pasquale, on scholarly opinion mining in the past few years. And we mostly worked with paragraph level knowledge extraction. So when you have a paragraph that documents most of the context about like who is talking about what, that's kind of easier in a way to extract automatically, because you can use identity recognition, relationship extraction, you can find the speaker and you can find the object of the speech. I mean, it's not an easy task, but it's a bit more doable. When you go to that kind of context, to a document level context in which you have a full scholarly article, there are a lot more problems, because as Joris just presented before, you lack a lot of context, because an article self-presents itself as a piece of science and without necessarily summarizing all the debate that there is inside that article. So this is our challenge. So basically to enable knowledge extraction from document level interpretations of this authorship attribution case. We start from a very small corpus. This is an early experiment in a way. So 3 articles, 2 in Dutch, 1 in English. And they, all of 3, they say something slightly different about who made this work. With one of these works just says, we don't know. 2 of them propose a specific person as the actual author of the Van der vos Reynaerde. We start from some competency questions, especially like what's the author identity according to the article of the publication. When and was the work created according to the scholar? What does the work reference, especially from an historical events, people, situations, all other works? And from an interpretation point of view, what do the scholar use to justify its interpretation, and what degree of certainty do they have in expressing these opinions? Like how speculative it is and how evidence-based it is, basically. To represent this kind of interpretation, we reuse a model which was developed here by Valentina Pasquale, Marilina D'Aquino, and Francesca Tomasi, which is the digital hermeneutics model. It is based on an publication. If you're not familiar with that, it's a it's a container for knowledge graphs, reporting and assertion. The digital hermeneutics model adds a factual level to it in a way that it avoids the decoupling of the scholarly assertion from the fact, the graphs it talks about. So you can have in a single container both the opinion and the facts that are argued. So basically both in our case, the poem we are talking about and the scholarly assertion about it. So we have 4 layers, the factual data is first, the scholarly assertions, the hermeneutical context, so all the process that led the scholar to process its findings, and the computational perseverance of the whole process. So what we need now is basically some way to extract this knowledge from an article and a solution to especially represent the discussion. So in the digital hermeneutics model, you are basically free to implement your own assertion level. And this assertion level, based on some examples. Maybe some of you are familiar with Midload, which was an application developed as well by Valentino Pasquale, in which they discuss mythologic artworks and discussions of attributions and references of the work. I suggest you see it because it's a very interesting project. But what we do is we develop the assertion layer based on CDOC-CRM. So what we are interested about, based on the competency questions we had, are who carried out the creation of the work, where was it created, which time or which time span does it has as the creation event, the identification, and if there is any influence or reference to the work itself. And this is what regards the creation itself. But we are also interested on who was the author. So we also try to model that. Surprisingly, CDOC-CRM doesn't provide you a way to express if a person speaks a language or has an occupation. So we reuse type as a solution. But we also document whether the person was part of a group, when they died, when they died, where they were born, where they lived, and so on. So this is basically all the small informations we want to catch for about this person. If you're familiar with the textual knowledge graph task, it is basically often developed as a pipeline in which you start from entity recognition, relationship extraction, then you link those entities to Wikidata, Wikipedia, and so on. Then you map everything for ontology, and you basically generate a tribal. So, for example, William is the author of the vos Reynaerde, 13th century beast epic, and what you would get ideally is the William, a person, is the creator of the vos Reynaerde in the time span of the 13th century, and the work has a literary genre as a beast epic and satire. So these pipelines are usually very long and expensive to train on because you need data that is apt to work with the dataset you want to extract knowledge from. And we explored in previous experiments the use of language models to bootstrap some parts of this process to both allow for more implicit knowledge information extraction from the documents, which is kind of necessary in some ways in scholarly assertions. And at the same time, you don't have to train them specifically, but what you have to do is to give clear instructions on the domain you want to have. And so we developed this pipeline by reusing previous experiments, but also by trying to inject as much as possible the competency questions we have. With language models, you have to also be a bit careful because if you ask too many things at once, you don't get a good quality in the answers. So you have to programmatically split the task into various steps. You have to avoid creating directly RDF data because they are very bad with RDF syntax and especially with the unification of the entities. So what we do is basically work with JSON, which is the industry standard, let's say, for schema completion from a language model point. Another limitation which has to be yet explored in its fullness is the fact that language models don't really read a lot of the things you send it because most of the information is concentrated in the introduction and the conclusion. So the problem is that when you try to extract the debate of a scholar around an article, if they only give you the conclusion, and the conclusion most of the time will be because they are very humble, they say, we don't really know what's the outcome of this process, and you lose everything. So what we do is to try to implement RAG, which is retrieval augmented generation. So what we do is we split the document into chunks. We do some embeddings on each paragraphs by avoiding like brutal splits of the paragraphs. And then we reuse the competency questions that we saw before to create some summaries. This way, we can have two main advantages are the fact that you get to still work with summaries in a way similar to a single paragraph, but at the same time, you keep all the context of the debate regarding like connected to the competency questions, which also ensures that when we try to apply the model, once we want to map the graph to the ontology, we can still get what we want. In the experiment, we actually used 5 articles, 2 of which we wanted to just test whether they would produce hallucinations because they were not talking about the creation of the vos Reynaerde. They were just talking about the vos Reynaerde in general. Okay. So the second step, of course, is just to perform NAIR, relationship extraction, and the rest of the classical pipeline, and then to map the rest of the graphs. The output, I will show you some snippets of it, is that, for example, in the first work, which is by Van Delle, the robot photo van den Reynaerde, which just means the author of the vos Reynaerde, is that the creation of the vos Reynaerde was influenced by the Cistercian order. I cannot speak so. That this event created the vos Reynaerde. It happened around 1250, and it was created by a certain Willem van Badelo, who was a monk of the Cistercian in Baudelo, and he actually died in there as well, because we know that this is a real person, and the philologist is basically saying that this person is very likely to have created this work. And he proposes basically that also he was active in this community, and that death of this monk happened in Baudelo, and it would basically be aligned with the rest of the document, which is in Flemish, and it talks about things that pertain the area, more or less. The second output we get from the other work is that in this case, we don't have any more identity, so we only know that Willem. But what the scholar proposes that he was probably active within the aristocracy, and since he translated the Roman de Reynaerde from French and adapted it in Dutch, he was probably able to speak Old French. And so it was also the work was probably inspired and refers to the Flemish aristocracy context, and it was developed just a bit more without expressing a specific time span in the 13th century. So we refer to the previous competency questions, and we try to understand the coverage of these competency questions on the extraction. And for the 3 articles, we basically get a good coverage. It's not perfect, but it's not bad. But at the same time, we have to account for what if the model is not wrong in not telling you a graph, but it's just that the scholar was not talking about a specific aspect. And at this point, the RAG step we did before, to summarize, helps us a lot, because we can just trace back what, as a middle layer, the output of the model with the RAG. And a lot of the times it happened that just during the RAG process, that sentence was either was not there, and then we can go from the provenance of the RAG step to the whole article and double check if it actually was not there. Most of the time, it was not the fault of the RAG step, it was the fault of our mapping, because sometimes, depending on the way the author phrased that question, was not perfectly mappable to the ontology. So the model, since it was an experimental step at this point, was still not complete. So we had to account for a lot more use cases. And as I said, this is an experimental step, and we just wanted to have a brief proof of concept. But the interesting thing is that if we scale this up to other articles, we can perform analysis on the different interpretations, we can perform distant reading, we can do also analysis on the metadata of the single scholars to trace whether, for example, in the last century, the opinion about if the author was Willem von Baudelo or not changed over time, and so on and so forth. So conclusions, in general, I hope I'm in time. Language models and based pipelines can extract these opinions. The problem is in the modeling itself, in our case. The knowledge graphs answered most of the domain expert competency questions. And the RAG integration allowed us to have an interpretability layer between the full article and the actual output, which is also very manageable in a way because it's like 3 paragraphs instead of a full article. As second conclusions, the pipeline sometimes might lose some uncertainty markers. For example, when we have circa 1250, because we should have a better way to program that span, but the temporal expression handling is a whole other matter computationally, so we have to integrate that as well. And also we are interested in trying to understand if we can represent the full step-by-step interpretation. So, for example, in the case of the why, like we get that the work for this scholar was created by Van Baudelaire, but why exactly do you think that? So the whole process, because all this person lived in this city is associated with this work, and so on and so forth. So we want to trace also that. So we have some improvements, but we also, if you have any suggestions, we are very happy to hear them. And currently, what we want to do is just to build a web application on this pipeline, so we can manage the whole process using a human in the loop, and to also validate it on the fly. To extend the biographical model with BioCRM, which is an extension of CDOC-CRM, especially for biographies and biographical data, and also to expand the assertions with the step-by-step documentation. So thank you for listening, and thank you for having patience with my mistake before. Yeah.
The time dimension is a very critical parameter.
Yeah.
How did you choose such parameter?
So first we decide whether the article is, depending on the sector of the article, we process it through OCR to Markdown, because it was a PDF originally. So in the Markdown suite, we managed to find all the subsections. So we use the full subsection, and we see whether it exceeds 500 to 24 characters. If it does, we split it into two, and then we mark at the end by adding like a 1.2 paragraph. So in the RAG step, the model will also tell us whether that paragraph was from which section. And we also don't brutally cut the section from like a point. We just check for the nearest end of paragraph. And if we see that the last sentence is doesn't have a new line, we just split in that case. If there is two lines at least, if there is only one line, we wait for the next paragraph. So it's a kind of simple logic, but we avoid the brutalization of the splitting in this case. Any other?
Go ahead.
Yeah.
Thank you for the presentation. And I have a question. Did you put everything in a single paragraph or a graph for each article? And the knowledge graph that you extracted?
So it's we have 3 articles, so it's 3 nano publications, and each nano publication is a single graph. So it's a single file.
But it's something that emerges usually for academics, collaborating publications in this environment that sometimes people estimate that this kind of process takes more time of personal assessment.
Oh, that's actually very interesting, and that was the reason why we wanted to implement a web application in a way. So the scholar's knowledge is always very important in this kind of processes, and that's also why we were accompanied by a competency domain expert. And we didn't calculate it, of course, so I'd say yes, no, we should. But the idea is also to integrate both of those, because one thing that it often happens is that the domain expert wouldn't have the exact competencies to build the knowledge graph by themselves. So this way we can simplify part of the work, but without avoiding while avoiding the computational overload of the domain expert. In a way, and and also I wanted to thank Joris van Zundert and Marilyn Aquino, who was not here. They helped a bit.
The models that you are something about function.
No, my assertion layer. My assertion layer. This one I refer.
Maybe I didn't.
Yeah, no, just the insertion layer. The problem was that we didn't have enough properties to map all the results from the language model's relations. So we missed a bit of that because the model managed to actually tell us what we wanted, but we didn't have the exact relation to map that part. Because for
very general ontology that I know it really helps you prompting things because it's very, very general and very complicated to be understood also by humans that study the primers like for years. So I was wondering if you think that maybe for this kind of tasks, it's better to use more straightforward ontologies and document setting things, and then maybe in a second step, then you convert it to, for example, CRM, more complicated sort of ontology.
Oh, that's actually a very good idea to have an additional layer because it was a consistent problem. For example, with the references or the influences, or even just the time span, because the model would tell you middle age, and that's a period. And then if you apply hard, like in the configuration, if you add hard RFID mapping without allowing for some bounciness, it just explodes down the length of the mappings we have to apply. But I think we are late. So thank you, Valentina.
Thank you, Andrea.